Hello, welcome back to Learn from a Layman. I'm Carl Christensen, back with Cameron Christensen, and today it's just us two. So, heaven help us,
I'm
because
sorry.
me too. But you get what you get, and you keep listening because you know it's what's best for you, if you catch my
Or
drift.
you're just so bored you want to listen to us.
I'd say we're actually incredibly entertaining, except that, anyway, whatever. Okay, I uh, think today we're going to tackle a very interesting subject. So please share this that we're going to talk today about phonetics. And phonetics is something that I think a lot of people deal with. Um, Either you spelling in school or your kids spelling in school or something like that. And you often curse if you speak English, the English language, because it's not phonetic. Today we're going to talk more about like the study of phonetics and what that means. Um, so we're gonna start with a little bit of talk about the International Phonetic Alphabet. Cameron, had you heard of the International Phonetic Alphabet before you just Googled it?
No. Well, that's not true. I did know that there was a phonetic alphabet because I am a little bit of a nerd and I
Hmm.
liked, watching um, My Fair Lady, and that adaptation to Pygmalion. He does write in a phonetic language in his notepad, which no one could read except for him.
Yeah, that's a good example. There are lots of it's funny. There are lots of movies about linguists, though, and it makes it seem like they're incredibly interesting. Generally, the job of a linguist is not as enthralling and really fit for the big screen. But I guess when you try to play it like that, there have been a couple. You know, The Arrival is a more recent linguistic, uh,
Mm, yes,
show movie. But
I like that
anyway,
show.
yeah, it was a good one. Okay,
Yeah.
so the International Phonetic Alphabet um, is well, it's been around for a while now. Actually, I don't know what the origin of it is, but it um, has all sounds produced in all languages of the world in one set, and for each sound there is one symbol, and that gives you the ability, obviously, then to use that one alphabet, that phonetic alphabet, to transcribe any language in the world. So essentially, if you know the International Phonetic Alphabet, um, you can then listen to any language, and obviously you're not going to understand it, but if you slow it down enough, you record it, and then you go back, you should be able to transcribe it. So given a particular sound, there's a corresponding symbol for it. So you can write down something that you don't understand, give it to somebody that speaks the language, and they can read it and understand it. And so that's pretty cool because most languages, the writing system does not exactly match the spoken language. And so if you have a non-native speaker of a language trying to transcribe, spoken language and then try to pass that on to somebody, it becomes essentially worthless. They're going to miss too many different sounds, too many different symbols that are necessary for a native speaker to be able to, turn that back into a spoken language.
Hmm.
With IPA, that's not the case. I see, Cameron, that you just looked up that
Yeah.
the IPA was
First made in,
1888.
yeah, and then revised a couple times in the next 2 decades. Also, we should remind people that IPA is the International Phonetic Alphabet and not a beer. So,
Well, it's also that, but um, yes, the it's taught in linguistics classes throughout across the world. There are other systems. There have been other attempts to make languages with phonetic, uh, you know, uh, Esperanto, for example. I think Esperanto might actually even use IPA as its um, orthography system. I know
NATO made their
orthography is
own
just a
one.
way to write down. I think that might be the case. It's been a while since I've looked into Esperanto, but phonetics is really useful in the way that it helps you understand the sounds that are possible. And so it's something also that I know there's a big job market out there for speech language pathologists, right? People that help children that are struggling making particular sounds. Usually your speech language pathologists have some background in phonetics, being able to understand what sounds are possible, and what movements the mouth makes and or the throat makes, and the vocal cords do, whether or not they're vibrating in order to produce a particular sound, helps them obviously then come up with a way to teach the child to produce that sound appropriately. So the IPA, like I said, used across languages, and so something that also comes with the IPA, though, is given different contexts, these different symbols, right? So for each sound in the of every language in the world, there's a corresponding IPA symbol, but in given different contexts, so different surrounding, different environments, these symbols are produced slightly different. So you can imagine if you have an A right before an M, am, at the end of that A, your mouth is already starting to move towards opening the air passage in the nose, so that the air can travel up to your nose, which is what is necessary to create the M sound. And so at the end of the A, in that case, an am, you have a nasal ending to that letter. So it's actually slightly different. So if you're doing a exact transcription of a particular sound recording and you want to be accurate, which you do obviously as a linguist, you're going to need to have a particular symbol, and there are diacritics, is what they're called, that you can then also add to your IPA symbols in order to better describe what you're hearing, what's being produced by the speaker.
So, I was a diacritic for once. I've never had a good one.
Oh my. Yeah. Okay. Yes. So, you know what? Okay. So I may have gotten jumped into the deep end a little bit here. It is. I think it is really useful though, and I've been a proponent of. I've talked to people about this for a while. I wish that we taught. It's not just phonetics, but like a basic linguistics class to high schoolers, because what happens is you get your first language learned very well, and then you start teaching high schoolers a second language, or before, whenever it might be, without any particular framework on which to understand language. You're essentially just chucking a new language at them and saying, "Good luck, buddy. Figure this out one. You figured the first one out, you can figure out the second one." Right. So
it doesn't work so well.
Yeah, well, it doesn't usually, and that's depending on your language teacher and whatever level of school that you had a language. Maybe you learn more or less of a language, but having a particular understanding of how language is produced, the sounds of them, the meanings of them, it would be useful. But that's me in my soapbox that I talk about often about a linguistics class. So a little bit more about phonetics. Another interesting, this not a tangent, but another aspect of phonetics is something called phonemes, and phonemes and phonetics are different. But they're very related. A phoneme it's more about perception than it is actually production. So phonetics is production. So when I'm actually making an a or an a or t. What is my mouth doing? What's actually coming out? What sound waves are being produced? A phone is more of what I think I'm producing in my head, and or what is perceived by somebody when they hear a sound, right? So in particular languages, different sounds are not. They're not the difference between different sounds are not meaningful. So, for example, in English, if I say butter versus butter. In that context, it might not be a great example, but you're not going to say, oh, that's a different word right there. You said butter as opposed to butter.
Here's a good one.
Yeah,
Mountain.
right. That's a flap. It's called a flap, and and in English and in that context, there's no difference. As soon as we hear that mountain or whatever, what's a glottal stop, or our mind just maps that right into that T, even though that's not a T sound that we're hearing. We don't struggle with that. We don't sit back and think, wow, what are they saying? It's automatically mapped in our mind to a T representation. And so that's a phoneme, right? And phonemes have different, what's called allomorphs. And essentially that's just different ways to pronounce the same phoneme. So I have, a T sound, and if it's in between two vowels, that can turn into a flap. It can turn into a D. It can, something like that. And P's and B's, once again, just depending on the context, all of a sudden the idea of this letter actually takes on different phonetic properties when it's actually put into in a language. So,
okay, that's good. But what happens when I'm on the phone and I'm trying to take someone's name down and I don't hear an N, but they say an N, So then we say, like Nancy, or
sure.
Instead of Mike. What is that?
There probably is a linguistic word, term, concept there. I can't off the top of my head come up with it for you, but I think it's demonstrative of the fact that in language we very much rely, and this is we see this all the time right now. I think I may have mentioned this in podcasts past, now in the last 9 months at least. We very much rely on more than just the sound. We rely on context and audio and visual cues. And so visual cues are gone on the phone. And so where you can look at the mouth, if you don't know if it's an N or an M that somebody's saying, instead of having to say Nancy or Mary or whatever, if you're in person, you just look at their mouth, right? Because you can tell by looking at their mouth, oh, that was an N.
You can't anymore. We're all wearing masks.
Exactly. And so that's one of the issues why masks are so difficult, right? When you are talking to somebody, and maybe you run into this every time you go to the drive-thru, right? And that's regardless of whether or not you're wearing a mask. But now, even if you are going to, get a takeout or whatever at the restaurant, you go up, they're wearing a mask, you're wearing a mask. You have no idea what they're saying. They have no idea what you're saying. Then there's a piece of plastic in between you as well. And so now all of these cues are completely gone. It's the phonetics, the audio sound, the actual waves are getting muffled. And so all of a sudden your whole language perception is it's hampered, it's handicapped, and all of a sudden now you don't. That's why it's so difficult. They're producing the sounds are mostly getting to you, but all the other cues that you generally use to understand and to better map what they're saying into a word and then a sentence, those are gone. And you now have to deal with just some very muffled audio sounds, which, as you can imagine, we don't always do well. It does give you a bit of empathy. I don't know if you can feel empathy for a computer, but you can imagine that's kind of what computers deal with when they do speech recognition. And speech recognition has improved substantially over the last, 15 years, even to the point where now it's pretty good. But without being able to speech recognition that can also train a camera on your mouth is going to be better than the speech recognition that just has to go on audio. So, and that's kind of what we get, right? We get the sound and the visual usually. So, but yeah, that's something that we have to deal with these days. Hopefully, not again for too much longer. But
So we're saying our speech programs could work better on the computer if we had a camera that was in conjunction to the learning.
I don't. Yeah. I almost guarantee the answer is yes. I haven't read the research in a long time. I've been out of school for a long time, but yes. I mean, generally, once again, you can just do your basic test of that situation by just saying, okay, talk to somebody while you looking at their mouth. Now close your eyes and listen to somebody. If you know them very well, then maybe there's no difference. Maybe because you have all the information built up for them that you need, so you don't need the visual cues as much. But if you're listening to a new speaker, let's say I work at a retail store, and somebody new walks up, and I can't see their mouth, versus I can see their mouth, it's going to be a very different outcome based on how many times I have to ask them to repeat what they said. So I feel strongly, without even having to look at the research, that yes, a camera trained on somebody's mouth would make a massive difference in the ability of a computer to recognize sounds. Now, whether or not the computer power has exponentially grown over the last 20 years. The ability to map the sounds and the image together and being able to in real time turn that into speech recognition, I'm guessing is already there, given the amount of computing power we have these days. I'm sure 10 or 15 years ago that would have been a little bit more challenging, but yeah. So the answer is yes.
So it's just depending, has someone written the program yet?
Exactly. And my go-to on this one is yes, there is no new thing under the sun. I meant that to not sound as sad as it is, as I made it sound. But generally that's a good thing, because people are out there doing lots of interesting things. So, all right. Let's see, any other phonetic information we want to talk about. So we talked about phonemes, we talked about allophones, we talked about the IPA and transcriptions. There are lots of interesting applications of computer applications. That we could talk about here for a while. I want to briefly touch on. We already touched on speech recognition. The flip of that is text to speech, and that's obviously taking the text and turning it into computer speech. And you hear that with Siri or
Android,
what is it?
Bixby,
yeah, Alexa, all those different things. Yeah. So, and that once obviously, as all of these things has gotten a lot better in the last 15 years, to the point where it's very good now. What I remember is that the way that they've gotten a lot better. So it used to be that they tried to given a particular, that they'd have to take the text, segment it, and then given each letter, assemble and then tell the computer to read each, in that case it would be a allophone that they're feeding, like a transcription into a computer and saying, this is what you need to read. My memory of my college class is that they were going more towards, I don't remember if the term was, they were using syllables, and they would have the onset and then the coda of a number of different syllables, because those are countable in any particular language. They'd have those recordings, and then they'd essentially have some computer algorithm that would smooth them together, and that's how they got the text-to-speech to sound far better than the very metallic and often unintelligible versions of in the 2000, early 2000s, mid 2000s versions of text-to-speech. So I'm sure there's probably even more there have been more changes since the last time I looked. It's not my area of expertise, but yeah, they take the phonetics is a very important part of it, certainly. Being able to feed words and then take from a word the actual phonetic meaning, the transcription of it, map that into something that the computer can then pull sound files or be able to um, synthesize different sound waves together to make it sound more human. Um, so lots of progress in that area in the last 10 or 15 years. Is all.
Yeah. Well, I would also imagine now with some of the large companies that most things go through, that there are user profiles that they've set up that just carry over from the devices that you use. So
Yeah, so
obviously,
that's
the more information that you have on a person, the easier it is to do a better recognition.
right. So that's speech recognition, and that is very much true. If you can train on a particular person, that's like I said before, like in our day to day, if so we're brothers, so we happen to have seen and heard each other talk a lot.
Well, I
And
meant
so
like Microsoft tracks everything that I do and say, and so does Google.
well that I'm getting there. Hold
Oh,
on.
okay.
So as humans, we do that with each other, right?
Yeah.
There's this theory of language that essentially we record all these instances of essentially everything in language, and we use them all. Um, and so we have this huge bank of knowledge, and we classify it in particular ways in our brain, our neurons. We've got billions of them, and we use them very well. Um, and so yeah, we essentially have particular models um, for different people. And so all these instances, we've trained our language models for our phonetics models for all these different people. And so now we can do that pretty well. And then obviously it does generalize pretty well across the speakers of a language, especially in a particular region, as you can imagine in different areas. If I go up to somebody that's learned English in in Australia or Canada or England versus here, sometimes if they're talking quickly, I'd be like, I don't know what you're saying. Slow down. And so that's an example of our language models breaking down. So now you can imagine, like I said, Microsoft, Apple, Google, Amazon, they've got lots of data built up about us, right? I mean, obviously there's lots of laws and rules about what they can save and but if they can even just abstract some of it, if they can take it and abstract and say, okay, well, I can't save all this according to the law, but I can essentially take some rules, I can make some rules and keep those and then dump the data. And so that's some of the types of things that they might be using our data for, and or in order to better train a recognition engine so that Siri can better understand you, or Alexa or whatever else, so that they can say, okay, I know how he talks, I know what he says. He speaks in a particular way, or this is a child's voice, a different voice recognition challenge there. So they are probably, once again, not my area of expertise as much, but are trying to do the same type of thing that we do as humans. And that would take us to another area that I'm at least cursorily familiar with, and that's neural networks. Neural networks are a recent, I think, deep neural nets is what is a machine learning algorithm. I'd say du jour, but it's no longer du jour. It's literally just the gold standard machine learning algorithms. And deep neural nets are essentially a way to take all this data, like that we just talked about, and build a model that will help you get the right output given a particular input. So imagine let's see. Well, this is used in lots of different scenarios now, but for speech recognition, I believe they're using deep neural nets, and they're doing that in a couple different levels. There used to be language models. There used to be dictionaries. There used to be I remember my terminology is slipping me at this moment. It's been so long. That there was an audio model. There's a sound model. Is that what it was called? Anyway, different. And these models are essentially there so that, okay, we get in new data. We need to be able to quickly take that data, compare it to other examples of the word, hat or something like that, and be like, okay, is this the word hat? Let's first, map this across, use our model to try to figure out what sound actually is incoming, and then let's try to map that into a word, and what's the probability of that word being said. And so, that's some of the steps that we kind of go through as humans as well. But the algorithm, the way that we map those together, and the way that we weight particular information, it was tricky for a long time. And well, I mean, not like it isn't now, but now we've got deep neural nets, which is essentially just the way that we interpret this information in the computer. So essentially we say, okay, here, computer, here's a load of information, a lot of sound files, a word mapped into words. Here's a lot of information about what words are said and how often they're said. And now we're going to give you a sound file, and we want you to tell us what's in the sound file. Go. And that's where the algorithm comes into play. Like, okay, well, how do we best do that? Well, now these deep neural nets essentially tell you, okay, well, I'm going to have lots of these different neural transmitters. Once again, my terminology might not be correct here, but different spots where it's like a network of neurons that this model is created, and as one gets excited, one matches better one particular node of this deep neural net, like as if I'm about to say asymptote, if I start hearing as, okay, that node of this deep neural net is getting excited. It's saying, okay, I think I'm hearing this, and maybe am is also getting excited because maybe I'm hearing that as well. Well, one's going to win out eventually, but as they're both getting excited, the nodes behind them are starting to get excited. The probability of those ones are going up now. And essentially, it's, once again, just a way to walk down that path of saying, okay, well, which one is it? And, oh, I see that this one's probability is significantly higher. Or this one, happens, and so it's this deep neural net way of saying, this is the way I'm going to walk down this path and try to figure out what's the correct way to use this information. So, like I said, that might not be a great explanation if you want to go to a machine learning specialist, or it's ASR is the term for automatic speech recognition. That's your Siri type of recognition stuff. They might have a better explanation for you, but that's kind of your layman, which is what we're going for. A layman explanation plus some. Plus a couple college classes. But yeah, deep neural nets, really interesting stuff.
I didn't feel too layman on that one.
Okay, I'm just giving the caveat that I know that people, and this goes back to our previous podcast as well, we do our best to not give fake news. But I know that every once in a while we've given some stuff that you could Google and you're like, wait a second, that's not exactly true. And that happens. And we want to be as correct as possible, and we will continue to improve. But yeah, we're not always the Bible truth, I guess, when it comes to some of these things, which this is more of a just becoming familiar with the idea and the concept. And then you can, if it interests you enough, dive down that rabbit hole, and then let us know what you found out and what we may have gotten incorrect. Yeah, I know there have been instances where I've listened to our podcast in the past and thought, oh, actually, no, that's not true. But try our best.
I find it interesting you say Bible's truth, because the Bible can be misconstrued fairly easily.
Okay. Right, exactly.
Maybe the
Look, I mean,
mathematical proof.
there you go, exactly. We're not axiomatically true. There you go. How about that? We're not
Oh, now you're gonna have to tell people what
an
axiomatic
axiom.
means.
Okay, right. So an axiom is the assumed an assumed truth. If you're trying to solve a mathematical a mathematic a problem, then you're often given axioms saying that X is true. X is an axiom. So if axiomatically means essentially like beyond question, it is established truth, and so that's what I'm saying. We're not that per se. Saying we're not fake news, darn it, but we're just here
I
to
like to think of us
inform.
more as the Onion Network. We try to
Right.
inform people, but if we get some stuff wrong or totally out of the ballpark,
I
it's
think that,
okay. You'll just laugh at us and have a good day.
yeah. Well, I think we're a little different than the Onion. Um, isn't the Onion supposed to be satire? I'm
You
pretty
take
sure
your
the Onion
pick.
is supposed to be satire. Ours is not supposed to be satirical, maybe occasionally inaccurate. Let's call ourselves the 90% accurate podcast. That would also be a good name for us. Um, that's a solid A minus, and I think that's about the kind of information. So hopefully, with this information, you find it approachable. So I know sometimes we might get a little bit technical on some of our physics podcasts, potentially even this one when we start talking about deep neural nets or phonetics and allomorphs and those types of things. But hopefully this gives you a bit of a taste. And like I said, and the
So
idea of learn it from a layman is to say, okay, this is we're going to get some basic information about this, maybe even some in-depth information when we invite people on, like Peter Vogel, who we had on a couple podcasts ago to talk about quantum physics. Our brother Matt talks often about his specialties, and those get a little bit beyond your layman. But even those, like I said, we don't do it's not like we sit and do a 20-part physics podcast where we talk about particular math physics rules or math equations and then sit and talk about them for an hour. This isn't a college exam. There are no tests after this. So,
no, but if you do listen to us, hopefully you'll score a C or better on your test.
yeah, well, um, yeah,
Just remember, B's get degrees, C's get you in trouble.
okay, so we're going to round this back to phonetics before we finish off this podcast. So once again, when we talk about phonemes, we're talking about the perception of a letter or a sound in a speaker's mind. So when I'm saying the word mountain, I think I'm saying a T in the middle, even if I sometimes say mountain. In my mind and the person that listens to me, unless they're not a native speaker and they don't understand what I'm saying, that is both perceived by the speaker and the hearer as a T, regardless of what actual allophone, the thing that's getting spoken, is produced by my mouth and heard by the hearer. So that's
All
allophones,
right.
and then once again back to phonetics, the actual sounds, the transcriptions. So if I'm going to listen to somebody talking in English and or a different language, and I want to write those things down, I can use this. I can use the IPA, International Phonetic Alphabet, which has a one-to-one mapping of sounds to symbols. And like I said, the one-to-one, that's the idea and that is the truth, but there are, given a particular context, changes to those sounds, to those phonetic symbols, and so then you diacritics as well that can then add particular information about the context. So that is the general idea behind phonetics. I'm sure there's a lot more we could talk about. I had 2 classes on it in college. A lot of it was transcription practicing, and then looking at sound files actually too, and trying to figure out different sound waves, how to recognize those and be able to look at a sound at a sound wave and say, okay, that's probably a T, that's probably a D, which is not something that we'll spend a lot of time talking about here. But if you ever get frustrated with English orthography, English spelling rules, teach yourself IPA. It will be not particularly useful day to day, but it will give you the personal satisfaction of saying, well, I might not be able to spell it in English, but I can darn well write it in a very phonetic and universally used language that is, that anyone would be able to read.
So, just as a reminder, before you submit your paper in IPA, make sure that is an accepted format.
I'd love to see a thesis. I wonder if that's ever been done. Like outside of linguistics, maybe it's been done in linguistics. But you could imagine a thesis done, like a doctoral thesis, written in IPA and handed in. That would be wonderful.
So for any of those that want to go the extra mile with their doctorate, write two. One in IPA and one in the other, and submit both and see if your teachers get a crack out of it.
Yeah, good luck. Don't think that's going to be happening anytime soon.
For any of our listeners in Utah that attend SUU and may have our father as an English teacher, feel free to submit at least something in IPA and see what happens.
I did hear, this reminds me of, we'll finish off with this questionable anecdote, which I believe is true, though I don't remember what the source of it is. I believe that in a university in Europe somewhere, and I don't even know how long ago this is, a student found that they could submit their doctoral thesis in Latin. It was one of the old rules of the university.
Like Oxford or Cambridge.
Yeah, I feel like that's probably true. Yeah, and so they did it. They wrote the whole thing in Latin and turned it in, knowing that their professors would not be able to read it, but that according to the laws of the university, they had to accept it, and that it got kind of off on that technicality. So. I don't believe that's the case with IPA, but like I said, IPA can be useful in a couple of situations if you're going to be a speech language pathologist, or you're going to be a linguist, or if you just want to be able to better understand the sounds of different languages. Look up your IPA tables, and they'll show you the different types of sounds, where the sounds are produced, and the symbols corresponding to where to that sound.
This is where it'd be helpful if we had a visual learning classroom instead of just an audio learning classroom.
That's true. Someday when we're huge, which
so if anybody you want to actually know what he's talking about, you can do a quick browser search or Google search. I think Google's an actual word now. So yeah, we can say Google search.
Absolutely.
And you can see the symbols and how they look cool, like a D3 or a T and a funny looking.
Yeah, that's J. Yeah. The post-alveolar affricate. Yeah.
Yeah, looks like some Greek symbol, and
It is really interesting, though. It gets their African sounds produced with the click sounds, and those are on IPA as well. So
we can learn Afrikaans. All right.
Afrikaans is Dutch, darn it. Well, we can have a different. I think you mean like Zulu or I don't remember what the languages are that have the click sounds in it, but it's not Afrikaans. Afrikaans is essentially Dutch. So.
Well,
for those of our South African listeners, they might be cursing at me now. It's close to Dutch, darn it. Okay, it's close. I know it's a different language, but as a Dutch speaker, Afrikaans, it's close. I mean, it's really close. The first time I saw Afrikaans written down, I stopped and looked for a while, and I was like, somebody misspelled a lot of words here. I was wrong. It's just a different language, but. All right. So with that, I'll leave you. We're going to leave our listeners with that wonderful
feeling of, did I actually learn something, or did I waste my time?
Well, hopefully the former, not the latter. But anyway, we got a new intro, and we've got some new music to take us out here. So hope you enjoyed our podcast today. Share with your friends, and if you want a particular subject covered by us, let us know. We invite
Yeah.
lots of family, friends in here.
I'll tell you what, I will give someone a $10 gift card to Starbucks if they actually give us a decent comment.
All
I
right.
will guarantee that for the first
All right. Well, there you
three
go.
people to give a good decent comment that we can actually answer or suggestion for us, I will give a $10 gift card.
They say that the comments help. Subscribing helps, and we have some subscribers. We mostly have people that listen to us on Spotify. They find us on Spotify. They listen to one of our physics podcasts. They listen to our orbital mechanics podcast. A lot of our technical podcasts, which are great. Hopefully, this one is not untechnical, but maybe not obviously near as technical. But for those people that are listening to this one, subscribe, tell a friend. It's supposed to help our podcasts, and so we've got lots of other interesting podcasts. We need to get back to our history series that we're doing. We're going to get the 1930s here soon, I promise. For those of you
really
that
want to
cliffhanger
get to the start of World War II.
Yeah, exactly. We got the 1900s through the 1920s, and then we've left people hanging. I'm sure they're with bated breath, wondering what the Learn It from a Layman podcast crew will talk about in the 1930s. But we're going to hit that one.
Just wanted to stay in the jazz era, you know?
In the meantime, hopefully you enjoyed this one, and we will see you guys back again next podcast.